So in this video, I'm going to talk about how to solve systems using linear combination. So there are three ways to solve systems of equations. We already talked about graphing and substitution, and in today's video, we're going to talk about how to use linear combination. So we can solve by linear combination when we add the two equations together to solve a system. So it really works well when the coefficients of one of the variables is equal and opposite. So you can see in this example here, the coefficient of y is equal and opposite. So when I add these two equations together, the y terms will cancel out, so I can use linear combination to solve this system. Before we get into solving, I just want to remind you of a few things. Remember that the solution to a system of equations is an ordered pair, because we'll have an x value and a y value in our final solution. Remember that when these x values and y values are plugged in, this will make both of the equations true. So here's how we solve by linear combination. You're going to first add or subtract the two equations together so that one of the variables cancels. Then you're going to solve for the remaining variable. Then once we have this value, we're going to take it and substitute it back into one of the equations to solve for the other variable. So let's go back to solving the system by linear combination. So we can go ahead and add these two equations together. So remember, when I add the equations together, I'm going to only combine the like terms. So like the x term and x term will combine. Remember, both of these are 1x terms. So 1x plus 1x will give me 2x. I have a plus y and a minus y, which is a plus 1y and a minus 1y. So those two terms will cancel each other out. And then I have 6 plus 8, which is 14. So now I have 2x equals 14. To solve for x, I can just divide both sides by 2. So when I divide both sides by 2, I'm left with x equals 7. So now to solve for the value of y, I can plug back into one of my equations. So I have x plus y equals 6. So instead of x, I'm going to plug in 7. So I have 7 plus y equals 6. So now to solve for y, I'm going to do the opposite of 7, and I'm going to subtract 7 from both sides. So when I subtract 7 from both sides, I'm left with y equals 6 minus 7, which is negative 1. So when I write my solution, I can write it as an ordered pair, which is 7, negative 1. So now let's try solving this system by linear combination. So notice that here I have an x term with equal and opposite coefficients, so I can go ahead and add these two equations together. So when I add them together, the x terms will cancel each other out. I have a plus y, which remember is a plus 1y. So plus 1 minus 7 is going to give me negative 6y. So I have negative 6y, and then I have 5 plus 13, which is 18. Now to solve this equation for y, I'm going to divide both sides by negative 6. So when I divide both sides by negative 6, this negative 6 will cancel, leaving me with just y. And then I have 18 divided by negative 6, which is negative 3. Now I'm going to go back to my equations and pick one of the equations. I'm just going to pick the first one, 2x plus y equals 5. And I'm going to substitute in negative 3. So I have 2x plus negative 3 equals 5, which gives me 2x minus 3 equals 5. Now to solve for x, I'm going to add 3 to both sides. So when I do that, I get 2x equals 8. And then I divide both sides by 2. So I have x equals 4. So my solution to my systems of equations is 4, negative 3. So now let's try solving this system by linear combination. Notice that I have a y with equal and opposite coefficients, so I'm going to go ahead and add my two equations together. So I have negative 4x. This is basically a 1x, so I have negative 4x plus 1x, so that's negative 3x. Minus 5y and plus 5y will cancel each other out, and that equals 5 plus 10, which is 15. So when I have negative 3x equals 15, I can solve for x by dividing both sides by negative 3. So when I do that, I'm left with x equals 15 divided by negative 3, which is negative 5. Now I need to figure out the value of y. So to figure out y, I'm just going to plug into the second equation. I have x plus 5y equals 10. I plug in x equals negative 5, and then I have plus 5y equals 10. So now to move the negative 5, I'm going to add 5 to both sides. And then the minus 5 and plus 5 will cancel, and you have 5y equals 10 plus 5, which is 15. So now I'm going to divide both sides by 5. And this cancels, leaving me with y equals 15 over 5, which is 3. So my solution now is negative 5, 3. So now let's try solving this system by linear combination. Well, notice that I don't have equal and opposite coefficients in this one, right? Because notice that I have 2x in both equations, but they're not opposite. If I go ahead and add these two equations together, I'm going to end up with 4x plus 2y equals 16. And that's not something that I can really solve because it has more than one variable in it. So what I'm going to need to do is make it so that one of my equations will cancel out, right? One of my variables will cancel out. So what I can do is I can take the equation and I can subtract it. So remember, subtracting is basically the same thing as multiplying the entire equation by negative 1, right? So I'm going to multiply the second equation by negative 1. So that means I'm going to make every term opposite. Okay, so I have, instead of 2x, I'm going to have negative 2x. Instead of minus y, I'm going to have plus y. And that equals, instead of negative 4, that's going to be 4. So now I can put this with the other equation, right? I can combine it with the 2x plus 3y equals 20, and now one of my variables will cancel out. Okay, so sometimes you have to subtract the equations because you can't actually go ahead and add them to get one variable to cancel out. So I'm going to cancel out x here because 2x and minus 2x. Then I have 3y plus 1y, which is 4y. So 4y equals 20 plus 4, which is 24. I'm going to now divide both sides by 4, which gives me y equals 24 divided by 4, which is 6. Now I'm going to plug back into one of my original equations. So I have 2x plus 3y equals 20. So instead of y, I'm going to plug in 6. So I have 3 times 6, and that equals 20. So I have 2x plus 3 times 6, which is 18, and that equals 20. So now to solve for x, I'm going to subtract 18 from both sides. So when I subtract 18 from both sides, I'm left with 2x equals 20 minus 18, which is 2. I can divide both sides by 2. So I have x equals 2 divided by 2, which is 1. So now I have x equals 1, y equals 6. So that is now the solution to my system of equations. So remember, when you solve by linear combination, you're going to first determine which variable you're going to try to eliminate. Then you're going to figure out whether you're going to add or subtract the equations together to eliminate this variable. Then we solve the resulting equation for the variable that remains, and then we plug this value back into either equation to solve for the value of the other variable.